Hi, this is Tech Clarence Chemistry. Today's topic is 7 crystal system in solid state chemistry. What do you mean by the term crystal lattice? The crystal lattices means it is the lattices that occupied by the crystal, which means that it is the arrangement of atoms in three-dimensional space to form the entire crystal is called the crystal lattices. It is the lattices in which the atoms are arranged. The lattices are in three-dimensional, so we can call the crystal lattice is the three-dimensional arrangement of atoms in which the entire crystal is formed. So another term is unit cell. The unit cell is the repeating unit of the crystal lattice, which means that crystal lattice, the entire crystal is formed when the repetition of unit cell is present. That is, the repeating unit of crystal lattice is said to be the unit cell. Let's take the dimensions of the unit cell. A unit cell. Unit cell can be represented by using the diagram. This is the unit cell. Here, this is the axis. A unit cell can be represented by using 6 parameters. The first one is axial length A, axial length B and axial length C. And the remaining is the axial angles. Axial angles such as alpha, beta and gamma. A unit cell can be represented by using 6 parameters such as 3 axial length and 3 axial angles. On the basis of the difference between the axial length and axial angle in a unit cell, there are 7 crystal systems are there. 7 crystal systems. In solid state chemistry, we first deals about the crystal lattice. It is the arrangement of atoms in the three-dimensional space to form the entire crystal. Then we discuss about the term unit cell. Unit cell means that it is the monomeric unit of the crystal lattice, which means the unit cell, the repetition of the unit cell that forms the entire crystal. So in solid state chemistry, there are 14 Bravais lattices and 7 crystal systems on the basis of the axial length and axial angle in the unit cell. Okay, the 7 crystal systems: C, T, O, H, R, M, T. These are the 7 crystal systems. C stands for cubic. T for tetragonal. O orthorhombic. Orthorhombic. H hexagonal. R rhombohedral. Rhombohedral. M monoclinic. And T for triclinic. Triclinic. These are the 7 crystal systems: cubic, tetragonal, orthorhombic, hexagonal, rhombohedral, monoclinic and triclinic. CTO, HR, MT. Axial length, axial angle. Okay, in cubic system, the axial angle is alpha is equal to beta is equal to gamma is equal to 19. In tetragonal, the axial angle is same as alpha is equal to beta is equal to gamma is equal to 19. In orthorhombic, same as alpha is equal to beta is equal to gamma is equal to 90. Clear? Then in the case of CTO, we consider axial length. In case of cubic, A is equal to B is equal to C. In case of tetragonal, A is equal to B not equal to C. There is one not equal to. B not equal to C. In case of orthorhombic, A not equal to B not equal to C. Clear? Then CTO is completed. Then we move to HR, that is hexagonal and rhombohedral. In case of hexagonal, the axial length is the repetition of the second, and in case of rhombohedral, the axial length is the repetition of the first. That is, it can be written A is equal to B not equal to C, and rhombohedral is the first repetition. A is equal to B is equal to C. Clear? Then we move to the axial angle. In case of hexagonal, alpha equal to beta equal to 90. Okay. Gamma is equal to 120. Clear? In case of hexagonal axial angle, alpha is equal to beta is equal to 90. Gamma is equal to 120. Then in the case of rhombohedral, alpha is equal to beta is not equal to gamma. Sorry, alpha is equal to beta is equal to gamma not equal to 90. Clear? In case of rhombohedral, alpha is equal to beta is equal to gamma not equal to 90. Okay. Then we move to the MT. CTOHRMT. Cubic, tetragonal, orthorhombic, hexagonal, rhombohedral, monoclinic and triclinic. In case of monoclinic, axial length is simple. A not equal to B not equal to C. Again, A not equal to B not equal to C. In case of axial angles, alpha is equal to gamma is equal to 90. Beta not equal to 90. Clear? In case of monoclinic system, the axial angle alpha is equal to gamma is equal to 90, but beta not equal to 90. Beta not equal to 90. Then we move to triclinic system. All the parameters are not equal to. A not equal to B not equal to C. Alpha not equal to beta not equal to gamma not equal to 90. In case of the first cubic system and the last triclinic system, in cubic system all are equal. In triclinic system all are not equal. In cubic system, A is equal to B is equal to C, alpha is equal to beta is equal to gamma is equal to 90. In case of triclinic system, A not equal to B not equal to C, and alpha not equal to beta not equal to gamma not equal to 90. Then we move to the Bravais lattices. Bravais lattice. Bravais lattice. Bravais lattice. What do you mean by Bravais lattices? The Bravais lattices simply which means that it is the different type of arrangement of atoms in the three-dimensional structure of the crystal lattice, which means that we know that we heard about many type of cubes such as simple cube, body centered cube BCC, and face centered cube FCC, and end centered cube. In case of simple cube, in simple cubic system, the particles can be seen only at the corners. In case of body centered cube, the particles can be seen at the body center and also the corners. In case of face centered cube, the particles can found at the center of the face and also the corners. Clear? These are generally called Bravais lattices. there are 14 Bravais lattices are there. There are 14 Bravais lattices and 7 crystal systems are there in solid state chemistry. Which are they? In cubic, there are 14 Bravais lattices. There is a secret code 3241121. This is the code to express Bravais lattices, which means that in cubic system there are 3 Bravais lattices. In case of tetragonal system there are 2 Bravais lattices. In case of orthorhombic system there are 4 Bravais lattices. In case of hexagonal system there is only 1 Bravais lattices, and in rhombohedral structure in only 1 Bravais lattices. In monoclinic system there is 2 Bravais lattices. In case of triclinic system there is only 1 Bravais lattices. Which are they? 3 2 4 11 21. Can you say 3 2 4 11 21? 3 2 4 11 21. That's simple. Okay, which are the Bravais lattices? In case of cubic system, simple cube, body centered cube and face centered cube are the 3 Bravais lattices. 3 Bravais lattices in the case of cubic system. In tetragonal system there is only 2 Bravais lattices. These are the first one, the simple cube and the body centered cube are found at the tetragonal systems. So in tetragonal system the Bravais lattices are simple cubic and body centered cubic. In orthorhombic system there is 4 Bravais lattices are here. The first one is simple cube, body centered cube and face centered cube and end centered cube. There is 4 Bravais lattices are there in the case of orthorhombic crystal system. In case of hexagonal system there is only 1, that is simple cubic. All the systems, all the 7 crystal systems possess simple cubic. Yes. Okay, all the crystal system possesses simple cubic Bravais lattices. In case of cubic, body centered and face centered is additional. In case of tetragonal, body centered cube is additional. In case of orthorhombic, body centered cube, face centered cube and end centered cube also there. In case of hexagonal, only 1 Bravais lattices is, that is the simple cubic Bravais lattices. In case of rhombohedral there is only 1 Bravais lattices, that is a simple cubic Bravais lattices. In case of monoclinic there is 2 Bravais lattices. These are simple cubic and end centered Bravais lattices. In case of monoclinic system there is 2 Bravais lattices are there. The first one is the simple cubic Bravais lattice and the remaining is the end centered Bravais lattices. And the final is the triclinic system. The triclinic system contains only 1 Bravais lattices, that is simple cubic Bravais lattices. This is the conceptual idea of the 7 crystal systems. Thank you.